Hello everyone, welcome to DevCon 2022. Today I would like to share with you the topic about connecting the real world and metaverse via real-time digitization. My name is Zhuo. I'm an AI evangelist at Intel based in People's Republic of China. And here are our global evangelist team. We have 4 evangelists based in America, in Europe, and China, and we are here ready to share information about OpenVINO Toolkit and possible application scenarios in how to use OpenVINO for speeding up and optimizing your AI inference. So today, I would like to discuss or talk with you about how to connect the real world and metaverse via real-time digitization, real-time AI inference technique. So first, let's look at metaverse. I try to use this figure to summarize the characteristics of metaverse. As we all know, metaverse is a real hot topic in recent years. So I hope this figure could help us to summarize some basic characteristics of metaverse. So first, we know the metaverse refers to a virtual world. It is a virtual world that we need to access through laptop, mobile phone, or wearable devices such as AR, VR glasses. And since it is a world, virtually, we all have our identities in this virtual world. And also, we could make friends, do some social events also on this virtual world. And also, we could have limitless experience and we need to access, maybe you need to access to the metaverse from anywhere at any time to experience this always on interaction. And also with all the information, with all the knowledge we have achieved or obtained in the real world, we could generate very creative contents. And also this limitless experience on the metaverse, on the virtual world. So that brings us to the question, how to connect from the real world to the metaverse. I believe there may be a lot of possible techniques to help us to achieve this goal. But for today, for our topic today, I would like to discuss with you one possible way. From my understanding, that real-time AI inference could be such kind of way to help us to connect the real world to the virtual world. Okay, so to help us for the real-time AI inference, to help us to do the digitization, which means that we can use real-time AI inference to project, to digitize the information. For example, the text information, all the text information around us, either the text information from natural sciences like the text information from billboards on the outdoor, or from all the documents or the books on this books text information. So how to digitize, how to encode this text information in the real world to the virtual world. I think one very highly possible way is the real-time AI inference. So first, let's take a look at what the challenge we will face to realize this real-time AI inference. So imagine this is you. You are a superhero. You've already trained your great neural network. As it reaches almost 100% of accuracy, you are sure it can save the world. But to do it, you need to first deploy it. So what can you use to deploy your very powerful neural network? Of course, I think the first thing that comes to your mind may be GPU. Okay, GPU is a very powerful computation device, but wait, you need only 15 frames per second. So GPU is rather overkiller. You're not able to fully utilize it. Moreover, it's rather expensive to use GPU for this solution, and you don't want to waste your money. So then, what is your other choice? Maybe the cloud. Of course, the cloud side is another very powerful computation environment you can use. But with that solution, you need to first build an API, and then you need to rely on the internet connection and wait for some time for the cloud API to come back with the results you need. And so, maybe just the CPU you already have. I believe you already have a personal computer or personal laptop. So, this kind of device already have CPU installed. It means that you have CPU at your hand from time to time. So can we just use CPU to do the AI inference? I think someone may say that using GPU to running the AI inference is too slow. But my question is it still the truth? I think today we have come up with this solution that you can still use your CPU to achieve real-time AI inference. And our solution is OpenVINO. From the name you could see, OpenVINO, open stands for open source. So OpenVINO is an open source toolkit that you could use for AI inference. And VINO, the name stands for Visual Inference and Neural Network Optimization. So at first, OpenVINO was designed for the neural network optimization inference for visual use cases. But I should say today that with our OpenVINO new release 2022.1, OpenVINO has supported and also optimized inference for other use cases like natural language processing and audio. It's not only for computer vision today. You can also do natural language processing. You can also do audio processing as well using our OpenVINO 2022.1. And for OpenVINO, to really enable our developers to use OpenVINO very conveniently and quickly, we have designed those 3 simple steps. Through build, optimize, and deploy, just follow these 3 simple steps. You can use OpenVINO to really deploy the neural network model on the device and also doing AI inference in real time. So here you could see our OpenVINO from the start, from the first step, from building the model. It has already supported a large number of deep learning frameworks that you could use to train your neural network model, like PyTorch, like TensorFlow, like Onyx. And today, for our OpenVINO new release 2022.1, we have also supported another deep learning framework, PaddlePaddle. PaddlePaddle is an open source deep learning framework by Baidu, and also it is the 3rd largest deep learning framework used in PRC. And also it has more than 2 million developers to use this deep learning framework. So you've seen our OpenVINO today has already supported almost all the mainstream deep learning frameworks that you could use to train your neural network model or the open source pre-trained model you could download. And after you have downloaded the pre-trained model or you have trained your neural network model, our OpenVINO could have this set of tools to optimize the performance for your neural network model. And for the deployment, our OpenVINO have supported different kinds of hardware devices like CPU, GPU, iGPU, and VPU. And also, you can do all those operations in different operating systems like Windows, Linux, and Mac OS. Of course, to use our OpenVINO, the first step is to install it. The recommended way is to use our installer. You can get installer by scanning this QR code, but you can also achieve the same in many different ways with like apt, yum, pip, conda, or docker. To get OpenVINO, once again, you can just start by scanning this QR code. Okay, like I just mentioned, there are 3 simple steps for you to use OpenVINO. The second step is using our model optimizer to optimize your neural network model. After this step, you will get intermediate representation files, which we call them IR files. Actually, there are 2 files within the IR files after model optimizer. The first one is the XML file with architecture of your model, and the other one is the binary file with weights and biases. But Model Optimizer not only converts your model to IR format, it actually performs a number of optimizations within it. For example, there's graph pruning or certain primitives like linear operations, for example, batch norm, are automatically fused into convolutions. And so here you could see how you can use Model Optimizer. Just type this simple command into your command window and also give some parameters like which model you would like the Model Optimizer to optimize for you. For example, in this example, you would like to optimize the model.onyx, this kind of different neural network model. And then you define the precision data type you would the model optimizer to optimize for you. For example, in this case, we are typing in the floating point 32. Of course, you have another choice, FP16. The model optimizer can also optimize the precision into FP16 for you. And then, just by typing in this very simple command, then you're done. Your model could be optimized with our MO. As I just mentioned, the product of optimization step is our IR files, and it's optimized version of your model. Some operations are fused, some are removed, and you get much simpler graph to run. So we can just see the comparisons between the upper graph computation and the lower graph computation after our optimization, after our MO, model optimizer. So you could see there are some computations that could be already optimized and reduced in our IR files. So, okay, now I would like to show you a live demo, and you could see how after you have obtained these IR files, how our model optimizer could do it. Our AI inference could do it for you. Okay, now let's see this live demo. Let's take a look together at how our OpenVINO can do this AI inference can speeding up the AI inference through our IR files. And for this one, I would like to show you our live demo of object detection with OpenVINO. So you can see this is one page of Jupyter notebooks that could do object detection with a live webcam. And here you can see you can download the model that you would use for object detection from our open model zoo. In this case, we're using this model SSD Lite MobileNet v2. And after downloading, we can of course convert that into the IR files. And after that, we can use the intermediate representation files, the IR files, to do the AI inference and load them into our device CPU. And with that, we can use OpenVINO to run inference on CPU for this live object detection. Let's take a look to see how it works. So you can see here, okay, it's not bad. You can see that I was in this window and I was detected as a person in this live object detection. And let me show you another one. This is a mouse. Yeah, it also could be detected in our object detection. So you can see this is how the live object detection could be detected. And the inference time is really fast just by using CPU. So we have seen how the IR files could really help us to do the AI inference just with CPU. We can achieve real-time AI inference, for example, for the object detection. And also, if you would like to quantize your network, your neural network model to int8, you can use our another set of tool, which we call it the post-training optimization tool POT, to give the converted model and representative data set. We can quantize our neural network model into int8 precision. Well, sometimes you may need more optimization for your pre-trained or self-trained neural network model. No problem. This is what Neural Network Compression Framework, NNCF, was created for. NNCF is a set of algorithms for optimizing machine learning and deep learning models for inference in OpenVINO. And NNCF could work with PyTorch and TensorFlow models. Here, within NNCF, we have 3 algorithms to help you to achieve this compression goal, like quantization-aware training, mixed precision quantization, and filter pruning. So with these 3 processes or algorithms, now you can do easily with NNCF, since you don't need to modify your model or learn the details about quantization. You can just have this experience of NNCF by scanning our QR code here to learn more and start using this very powerful tool of NNCF. Okay, so after the second step of model optimization, now let's come to our last step, inference on devices. So this is the third step, the last step. You need just 6 lines of code to run the inference. Let's take a look at an example. So first, you import the OpenVINO and then load your data, initialize the inference engine, and load the exact network or exact model into specific device. In this case, the device name we define our CPU. And then giving your input and getting the results from output node. In the simplest case of image classification from this to this. Yes, you can just use 6 lines of code to do the image classification, and now you have the result instantly. It tells you that this image is a dog. So from the example we have just shown you, you can see the device name we defined in that case is CPU. But actually, there are a few choices that you could do for the supported devices here. We actually support many different Intel's hardware like, of course, CPU. The CPUs like i3, i5, i7, Atom, or Xeon are all supported. Besides CPU, we also support GPU. And when I say GPU, I mean the GPU integrated into your CPU. You don't need any discrete GPU card. GPUs that supported are like Iris, Iris Max, Intel UHD graphics. And also, besides those, we support Myriad. Myriad means the Neural Compute Stick 2 and USB accelerator. And also, for our 2022.1, we're very glad to bring the Auto device as the selection of the device name here. If you don't know which device is best for you for this specific case of AI inference, we can just choose it automatically when you put down the name Auto here. So here within the Auto device, you can see we've actually developed this Auto plugin. Within Auto plugin, we actually include the CPU plugin for doing inference on CPU and GPU plugin for doing the inference on GPU. And the Auto plugin discovers the accelerators and capabilities in the system and chooses and configures the device matching to your neural network's precision, topology, and user's performance requirements. For example, if you would like your neural networks to have this latency as your preferred performance, then latency first would be considered as a configuration for our Auto device. But sometimes you would like the throughput as your first choice for your AI inference performance. Then you can put down in the configuration as performance throughput first in the Auto device configuration. So you can see our Auto device could really help you to maximize your AI inference performance. And also, sometimes we know that neural network loading to GPU and VPU takes longer than loading to CPU. So sometimes we will have this kind of impression that when we start up an AI inference on GPU or VPU, sometimes it is even slower than CPU. So in this cases like video conference, camera use case where initial inference latency is important to user experience, then working on that kind of inference on GPU and VPU at first may not be a very perfect choice. But now with our Auto device, we have provide you this kind of experience that Auto will start inferencing immediately on the CPU and at the same time transparently shifts the inferencing to the GPU or VPU once the loading of network to GPU or VPU is ready. So it will dramatically reducing the time to first inference. It will really help you to experience much faster inference for real-time AI inference. And also, besides the Auto device, for the supported device name here, we have provided you another choice called hetero. It means that you can split your graph into 2 or more parts and schedule some operations on the first device and some operations on the second one. So why we are doing this is because some operations can be faster on GPU and some are on CPU. For example, you can see that here we have split this kind of computations like group convolution on GPU because we know that very complicated convolution computations are really doing fast on GPU. And also we split the add on convolution computations on CPU. So by splitting these computations on different devices, we can really also maximize the AI inference performance we could achieve. And also besides hetero, another choice is multi. It means that OpenVINO can copy your model across devices to increase the throughput. If you have many frames per second, you can schedule some of them on the GPU and some of them on CPU and process them in parallel. So you can see that this could really also speeding up your AI inference performance. And okay, besides that, I would also like to mention another very important new features for our OpenVINO 2022.1. So for this new release, we now have officially supported dynamic input shape. So what kind of dynamic input shape is? Try to remember or try to imagine this kind of use case that in this natural language processing case, sometimes you may have some questions to ask for the machines to answer. For example, you may ask a machine like, what is the weather going to be like today? This kind of questions. And also, sometimes you may have these complicated questions which have longer words in it, like, what is the term for a task that generally lends itself to being solved by a computer? But sometimes when you feel a bit upset, you just need a good laugh. So you may say a very short sentence like, I need a good laugh to the machine. So you can see when you have different questions to ask the machine, you will have different lengths of sentences that need to be input to the NLP model. So in this case, we are referring to the dynamic input shape of this neural network NLP model. So you can see in these cases, like what does OpenVINO mean and what is the term, this kind of questions, each question have arbitrary number of words within it. So for them, when we input these different lengths of sentences into the NLP model, we are referring to that the input shape of each sentence, the input tensor shape is really changed on every inference call. So previously, in this dynamic input shape, we need to do some padding to pad each sentence to the same length for the neural network to do the AI inference. But that sometimes will cause the bad performance, sometimes cause the accuracy to drop. But now for our new release, 2022.1 release, now we have support the dynamic input shape. So now there's no padding needed to be done for this case, for this natural language processing case. And what we need to do, let me share our solution with you using this simple example. You could see here, when we load our text, when we initial our inference engine, and we read the model, load the model, you could see that for the input, we just need to tell our inference engine which input has the dynamic shape on its dimension. For example, in this case, on the second dimension of our input, we have the dynamic input shape. So we just need to tell our inference engine, okay, on this dimension, we have the dynamic input shape. The shape on this dimension could be dynamic. We just tell using this kind of line of command to tell the inference engine this dimension has dynamic input. Then the model can then work accordingly to continue to load the model to, for example, the CPU to carry on the further inference. So remember, on this new release, we do not need to pad any data to make the input shape to have the fixed length, to have the fixed shape. We have already support the dynamic input shape. And also for the performance, I would like to show you that how OpenVINO could really perform on different CPUs. So in order to show this performance, we have selected 3 models: the ResNet for classification, in ULO for detection, and DeepLab for segmentation. The tests were performed on a standard computer with batch size equal to 1. This computer wasn't overclocked or water-cooled. It's standard computer like yours. So in this chart here, you can see throughput in FPS for FP32 data precision OpenVINO models. The best performance is for the 11th generation of i7 CPU. Of course, it is a very good 11th generation of i7. It's a new CPU, but you don't need to have the latest CPU. Actually, look at these results from the 8th generation. And also, you may have realized these 8th generation CPUs are from 2017. They are 4 or 5 years old. But for the classification and detection, they also provide our real-time inference, and even segmentation is not so bad. It reaches almost 20 FPS for the cheapest i3 processor. You can also check other models and other hardware by swiping this QR code. And if you want to measure performance for your networks, just use Benchmark App tool from OpenVINO development package. So just by typing in this kind of command, you can use our Benchmark App tool to measure the performance of our OpenVINO on your own machine. And another very important feature of our OpenVINO I would like to introduce to you is our Open Model Zoo. For our Open Model Zoo, we have and share more than 270 pre-trained and optimized models like these. So you can see this is human segmentation that you can use our pre-trained model to do. The latency is about 200 milliseconds. And also our Open Model Zoo includes the pre-trained model for human tracking. For this car detection scenario, and also for this face detection, sex, age, and emotion classification scenario. And also this very interesting gesture recognition. And all these kind of pre-trained models are provided in our Open Model Zoo. All of them are now available at our GitHub repository. So if you're just starting your journey and don't have any trained model, you can use one of ours. And next, I would also like to introduce to you the deep integration of OpenVINO and PaddlePaddle. So as just mentioned, our OpenVINO now has carried out this deep integration of supporting PaddlePaddle. And PaddlePaddle is the 3rd largest deep learning frameworks used by more than 2 million developers. So with this support of PaddlePaddle deep learning framework, OpenVINO can already directly feed the PaddlePaddle model to our OpenVINO inference engine. And this is an overview of the PaddlePaddle applications. So the PaddlePaddle have provided our developers a set of deep development and training tool for our developers to develop or download pre-trained neural network models. And after that, they provide a set of compression tools called PaddleSlim. And also, when developers got this output paddle deployment model for deployment, now with the deep integration of our OpenVINO and PaddlePaddle, now you could see that the models could be directly fed to our OpenVINO. And so what the advantage that the developers will get through this deep integration? The first thing I want to point out is that because PaddlePaddle has open sourced more than 400 leading pre-trained models. So with this deep integration, our developers could use, besides our 270 plus pre-trained models provided in our Open Model Zoo, the developers can also leverage the more than 400 pre-trained models from the Paddle Model Zoo. So you now have more sources for pre-trained models. And also with this deep integration, you can see that the Paddle model could be directly fed to our OpenVINO runtime, to our inference engine. And for the deployment, you can use both our just introduced the device name or our model server to deploy these Paddle models. So you can see this integration of this Paddle deep learning framework could also benefit a lot for our developers. And next, let's run the demo.
Okay, next, let's run a live demo. For OpenVINO to run inference for OCR. So here in this one page of Jupyter Notebook demo, we select the OCR model of Paddle OCR. This is an open-sourced OCR model with PaddlePaddle as the deep learning framework. So as we just introduced, now OpenVINO can directly read the Paddle model and do the inference. And also, this model is an ultralight OCR model with very small model size. So we choose this one to show you that even with this ultralight OCR model, the result is pretty good. And also, OpenVINO can help to achieve real-time AI inference. Okay, now let's run all the codes together. Okay, you can see here, we can move the book near and far. Okay, the text information could be extracted from the book. And of course, the inference time is really fast, gives us about 40 FPS. So it could really give us the performance of real-time AI inference.
Okay, you have just seen me running a live demo of using OpenVINO to run the inference, the real-time AI inference with Paddle OCR. And you can see we are just using a one page of Jupyter Notebook to run the whole demo. Actually, the demos we just presented to you are available in our Jupyter Notebooks repository. You can find more than 25 useful notebooks teaching you how to use different aspects of OpenVINO, and new ones are appearing at all the time. You can run them on your computer by just following these 4 steps. So the first step is to just create a virtual environment for running the Jupyter notebooks. And the second step is clone our repository from GitHub and then install all the requirements for running the OpenVINO notebooks. And after that, you can launch all the notebooks in Jupyter Lab. And so you can see by running all the codes from this one page of Jupyter Notebook, you can see instantly on the notebook how the AI inference by using OpenVINO could be. And this is how we use OpenVINO to run the Paddle OCR inference I've just shown you. So in today's sharing, you can see that we can really use OpenVINO to perform the real-time AI inference for text information. Of course, I believe there are all kinds of information, including text information, video information, and audio information in our real world. And sometimes we need to digitize them, encode them in a digital form, and store them, project them in the virtual world, and use these different kinds of information to create a more colorful or more creative information contents in the virtual world, in the metaverse. So I really believe that using our OpenVINO to do the real-time AI inference is a very good path, is a very good bridge to help you to connect the real world to the metaverse. And I have shown you with our live demo how we can use OpenVINO to achieve that. So don't just believe me, try it yourself by first downloading and then installing and using our OpenVINO notebooks. Just try it yourself. And last, I would like to really encourage you to join our hoodie challenge. We would like to give out 10 OpenVINO hoodies like these to you if you just follow these 6 steps here. So how to join our hoodie challenge? The first step is to clone our OpenVINO notebooks repo from our GitHub, and then to complete all the installation of OpenVINO books using our wiki webpage. And then please run the notebooks within our OpenVINO notebooks repo. For example, notebook 401 for object detection, like the one I've just shown you. And there are also some very fantastic live webcam notebooks you can run in using your own live webcam. And after running that, please create a video or GIF with you and your inferencing results, at least for 10 seconds like this. For example, you could run object detection and also human pose estimation, human action recognition, and made this very interesting and fantastic GIF or just short videos. And when you've done that, please post it on your LinkedIn and add hashtags OpenVINO #hoodie challenge, and then send a screenshot to me at zhuo.wu@intel.com before April the 10th. And the first 10 people to finish this kind of task, we will give out our OpenVINO hoodie to you. So welcome to join our hoodie challenge. Okay, that's all my sharing for today. Thanks again for listening.